Hello everyone, I'm Tarun Prajit from CIS AI, graduating in Sri Venkateswara College of Engineering, and today I'm here to discuss about Quicksort. And in this presentation, we are going to explore one of the most efficient algorithms in computer science, that is Quicksort. Quicksort is one of the most efficient sorting technique, and it is a comparison-based sorting algorithm that relies on partitioning arrays or lists into smaller subarrays. It was developed by Tony in 1959. Explanation of quicksort algorithm. That is the process how the quicksort algorithm works. The quicksort algorithm process can be divided into three steps. One is choosing a pivot element and next partitioning it to the pivot element and doing the process recursively. That is, first we will select an pivot element and we will keep that element in the center, in the middle, and we will keep two subarrays. Which is present in the left side to the pivot element will be less than the pivot element, and which is present in the right side will be greater than the pivot element. And doing this process recursively through an n number of times gives us the sorted array. This is an algorithm for quicksort program. In this algorithm, a quicksort function is called, and inside the quicksort function, there is another function called partition function. We saw the algorithm of the quicksort, and in that algorithm, we saw an partition function, and this is that partition function. This is an algorithm for that partition function. The partition function is used to divide an list or an array into subarrays and arrange it. It is used for rearranging the array or list. There is also a simple pseudocode to implement the quicksort algorithm. In this slide, there is an example of how does a quicksort algorithm works. And through this example, I am going to explain you about how does a quicksort algorithm works. First, we have taken an unsorted array of elements 5, 2, 9, 3, 6, 4, and 8, and we have taken the pivot element as 5, which is placed at the leftmost corner of that array. And when we take this pivot element, we will place it in the center of the array, and that is in the middle, and we will gather the elements which are lesser than the pivot element. That is, the elements 2, 3, and 4 are lesser than the pivot element 5. And we'll place that in a subarray in the left hand side of that pivot element. And the elements remaining than that, that is the elements which are greater than 5, that is 9, 6, and 8. We will take those elements and we'll place in the right hand side of the array. And we will do this process recursively over a period of time. We will get an sorted array. For example, if we take the right subarray, which is present at the right hand side of the pivot element, that is 9, 6, and 8. In this case, if we take 9 and if we place 9, if we take 9 and if we take that as pivot element in the next recursive function, we will place that in the center and we will place the elements which is left lower than 9, that is 6 and 8. We will place both of that in the left hand side, and there is no element to place at the right hand side. So this, if we repeat this process recursively over a period of time, we will get a sorted array, that is 2, 3, 4, 5, 6, 8, and 9. Through this process, the quicksort algorithm works in this way. And the sorted subarrays will be merged together at the last of the quicksort algorithm. And this quicksort algorithm is not only performed only in arrays, it can be performed in lists also. Quicksort algorithm is one of the most efficient algorithm to sort an array. There are multiple sorting techniques like merge sort, selection sort, etc. But quicksort is the most effective way and it is used widely in the computer science field. In this slide, we will discuss about time and space complexity of quicksort. In general, time complexity means the amount of time required to execute an algorithm is known as time complexity. In most of the cases, it is complex to calculate the amount of time required to execute an algorithm. So, we will be calculating the number of basic steps required to execute an algorithm. That is known as time complexity. And there is three scenarios, that is worst case, best case, and average case in time complexity cases. In case of a quicksort algorithm, the time complexity is big O n log n in general and big O n square in the worst case, and in case of average, it is big O n log n. Quicksort is a fast sorting algorithm for average and best case scenarios, but may be inefficient for some specific inputs. This is the time complexity of quicksort algorithm. When we go to the space complexity is nothing but the amount of space required to execute an algorithm is known as space complexity. In case of a quicksort algorithm, the space complexity is big O log n in general and big O n in the worst case. Uses recursion to sort and subarray. That is, then in quicksort algorithm, we will use recursion to sort and subarray, through which we can get an sorted array. In this slide, we will be discussing about the advantages and limitations of quicksort algorithm. And when we come to the case of advantages, the first advantage is it is highly efficient. As we know, the quicksort algorithm is one of the most efficient algorithm which is used in the computer science to to sort an data or an array. It is used most widely in all the cases for sorting an array. There are multiple sorting techniques, example, selection sort, etc. But it is one of the most efficient algorithm which is used at the present stage. And fast sorting algorithm for typical data sets, and it can be optimized for practical use since it has low overhead. When we come to the case of limitations, the worst case time complexity can be slow. That is, the amount of time required to execute a program is known as time complexity, as we discussed above in the previous slide. And that time complexity can be slow in the worst case, making it inefficient for certain types of data. Sus- Sustainably, to a security vulnerability called an pivot attack, pivot attack, which can cause it to degrade to big O n square time complexity. Through this presentation, we have discussed about the introduction for quicksort and how does a quicksort work, even pseudocode for quicksort, algorithm for quicksort, and how does the algorithm works. And we have discussed about the advantages and limitations of quicksort, which is the advantages. It is the most efficient sorting algorithm, and it can be used in a wide range. And we have discussed about the time complexity, which is the time required to execute a program, and we have discussed about the average case, worst case, and the best case scenario for the time complexity. And we have discussed about space complexity, which is the space required for an algorithm to run. And we have discussed about the best case, average case, and worst case of the space complexity for quicksort algorithm. Quicksort is a powerful sorting algorithm with great strengths and few limitations. With a solid understanding of its inner workings, you can decide when to use it and when to choose another algorithm. That the quicksort algorithm is the most efficient algorithm which can be used widely, and if you know how to use it, and if you have the deep understanding of the quicksort algorithm, you can decide when to use it. That it quicksort algorithm has certain limitations, and in those scenarios you can use another algorithm like selection sort in those cases, so that it can be more efficient, the program can be more efficient. The quicksort algorithm is slow in certain stages. In those places, you can use an selection sort algorithm or different algorithm which is more convenient to use there, so that the efficiency of the algorithm is increased. Thank you for listening throughout the presentation about quicksort, and I am happy to have you here, and I hope you have learned something new about quicksort and time complexity of quicksort, or even space complexity of quicksort, something new about the quicksort. If you have learned about it, I'm very happy about it, and I hope you have learned something about it. Thank you.